For this project, I thought I'd do a video on the SN2 reaction, mostly because I did not understand it when we learned it. So I know this is evaluated by super smart TAs and LAs, and maybe even the omnipotent being that is Dr. Pham, but this video is for all the less academically endowed folks in the same boat as me. If you respond yes to any of these questions, please watch this video to help ensure that you don't get a 50% on your midterm like I did. So basically what I want to do is discuss SN2 purely in layman's terms, and we'll break it down so that hopefully even a 7-year-old could do it, because that's about the level I like things explained to me. The idea is that too many big words and complex concepts leaves you, or at least me, with too many places to get confused. So my hypothesis is that by making things ultra simple, the concept will be easier to learn, more fun, and easier to memorize. Okay, here goes. So first let's look at a super simple SN2 reaction. What's going on here? Well, we can see that there's a Cl on a wedge at first, meaning it's pointing towards us. Then after a reaction, it magically becomes a Cn with dashes underneath it, and the Cl is off on its own after being kicked off. The Cn in this case is our nucleophile, the mean kicker-offer. I know I promised no big words, but I'll give a simple definition. So nucleophile is basically just a negatively charged molecule that wants to get rid of this charge by attaching to a molecule with a positive charge. Makes sense, right? So we have the Cn floating around and it wants a positive charge. It just so happens that the carbon attached to the Cl is harboring a good partial positive charge because the Cl is electronegative, meaning that it's greedy about shared electrons and pulls them towards itself. What's important is that the nucleophile is not also a strong base, because then it will react with too many things, since we know that strong bases are very reactive. We want this to be kind of in the Goldilocks zone, and there's a good chart of strong nucleophiles for SN2. Don't worry about that part that says E2, that will confuse you later on in the quarter. The Cl is known as our leaving group because it leaves. So if you understand the concept of pKa, then you can Google low conjugate acid pKa values to know good leaving groups. If you don't know that concept, then please Google it like I had to, or refer to this table. So what about this DMF thing that I haven't discussed yet? Well, that's the solvent, or stuff that the reaction is sitting in as it happens. The reaction juice, if you will. The issue is that the nucleophile is negatively charged, and any spare H+ protons that are common in many reaction juices will cause a reaction with the reaction juice rather than the substitution reaction that we want. This is why SN2 reactions need to be in aprotic reaction juices, ones without H+'s floating around. So here's a list of some super common ones. DMF is right there. So finally, let's get to the attack part. Like what the first midterm did to me, the carbon attached to the Cl gets bum rushed from behind. This is because there are less things in the way and no one is watching. Because of this, we now have to flip the stereochemistry for everything, essentially making all wedges dashes and all dashes wedges that are attached to that carbon, since the backside attack changed the orientation of the molecule. Super root of Cn. Regarding access to the carbon from the back, tertiary carbons have too many fat things attached to them. There are too many things going on. So the nucleophile can't access the back and is too scared to confront the Cl leaving group face to face, so the reaction doesn't happen. This is why SN2 only happens with methyl primary and secondary carbons. Anyway, that's pretty much SN2 reactions in a nutshell. I hope you enjoyed, and I really hope the extra simplified explanations were accurate and helpful. This took a super long time. Again, not academically well endowed. So yeah, I hope this helped, and if you are still confused, then welcome to my world.